Assalamu alaikum. Hope you are doing fine. The first chapter in 11th physics is the nature of physical world and measurement. In this video, we are going to discuss the first part of this chapter, that is nature of physical world. Before getting into the subject, we will discuss some of the basic things. Now, let me tell you what is science first. The word science has come from Latin verb scienter. Latin verb scienter means to know. To know. So what is science? Science is the systematic organization of knowledge gained through observation, experimentation and logical reasoning. We can classify science broadly into two, as physical science and biological science. Now, this is about classification. We classify science into two. One as physical science, another one is a biological science. So what is this physical science? I abbreviate physical science as PS. Write PS, it represents a physical science. Physical science is that branch of science which deals with the study of non-living thing. Here, physics and chemistry comes under physical science. Next we have biological science. I represent biological science as BS, whereas physical science was represented as PS. Now, biological science is nothing but botany and zoology. In biological science, we study about living things. So, in simple words, the branch of science that deals with the study of living things is referred as biological science, and botany, zoology comes under biological science. If you compare these four branches of science, the most basic is nothing but physics. Physics is the most basic branches of science. The most basic branch of science. Then, how it was originated? Let's discuss about that. Origin of science. Origin of science. The curiosity-driven observation is the reason for the origin of science. Curiosity. The human being is highly curious. It is said when the Lord created Adam and started feeling soul in the body, the part of body which received the soul started raising up. So, we are highly curious. So, this curiosity-driven observation of any natural happening is the reason for the origin of science. We can take the example of the discovery of gravity by Sir Isaac Newton. We are aware of that. It is as a result of the observation. It is said he was sitting under an apple tree and found an apple falling from the tree. This observation made him to discover gravity. So, for the discovery of anything, the most important thing required is nothing but curiosity along with observation. Now we'll go ahead. So, let me write this important points. The origin of science is nothing but curiosity driven observation of any natural phenomena or natural happening. Here phenomena represents some kind of a happening. This might be raining, blowing of wind, or something else. Then here the word science. The word science was coined in 19th century. 19th century. Earlier to that, science was named as natural philosophy. Science was named as natural philosophy. Natural philosophy. Now repeat. Science was known as natural philosophy earlier to 19th century. And that's the reason why we have MPhil or PhD, the Master of Philosophy or Doctor of Philosophy. Here philosophy represents science. Then we will discuss about scientific method. There is something called a scientific method. Scientific method. What is this? Method. Method means a process, a procedure to be followed to carry out something. In a similar way, scientists follow a method to carry out their research work. We call this procedure or method as scientific method. And in simple word, scientific method is an approach to find the reason for some natural happening. Scientific method is a step-by-step approach to study a natural phenomena, to establish a law or concept that governs it. The scientific method have got certain features which are as follows. First, observation. Next, experimentation. Third, reasoning. Fourth, mathematical modeling. Mathematical modeling. And the last one is verification. These are the steps followed in a scientific method. This I will explain with the help of a simple activity. Here I have this setup to explain scientific method. I am hitting this steel rod with the help of a homemade sprit lamp at this end. It is common observation that when we heat a metal rod, heat spreads throughout the length. If I heat this rod for some more time, another end of this rod will get heated up. Soon the heat will reach this end. That's the common observation. If I try to find the temperature of this rod throughout the length, for that I require a thermometer. Here I have a digital thermometer. I am going to use this to measure the temperature. I turn on this. I will place this thermometer at different part of this rod. I place it here at this point, which is far away from the point or the end where I am hitting this rod. The temperature read is 32.6 degrees Celsius. Now I bring it little close. So the temperature read is 35 degrees Celsius. Now let's keep increasing. Now I'll bring it more close to this heating end of the rod. Now the temperature read by this thermometer is around 40 degrees Celsius. This shows that as I am getting closer to this end, the temperature of the rod is increasing. Now this point of the rod shows more temperature. It is around 50 degrees Celsius and keep increasing. Now I move closer to the end which I am heating. Now the temperature of this point of rod is more than 70 degrees Celsius. Now from this we can conclude that as we move away, the temperature of the rod is decreasing. This shows that heat is spreading from this point to this end of the rod. What I have done is called as experimentation in a scientific method. If I try to establish an equation which relates the temperature and the length of the rod, then it is called as mathematical modeling. Then if I verify that with some other thing, then it is called as verification. These are the steps in a scientific method. Now let me tell you what is physics. Physics is that branch of science that deals with the study of nature and natural phenomena. You have physics is the branch of science, that deals with the study of nature and natural phenomena. Here when we say natural phenomena, as I told you earlier, it may be raining, lightning, blowing of wind, or anything which occurs in nature. The soil erosion, eruption of volcano, rotation of Earth around Sun, the revolution of Moon around the Earth, all these things come under natural phenomena. We learn about all these things in physics, that how the gravitational force occur between two objects, or what is mass, and then many more things. Now, when we study physics, there are two approaches. You need to remember this. There are two approaches in the study of physics. One is two approaches. One is unification. Unification. And the second is reductionism. 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 These are two main approaches in the study of physics. I'll tell you one by one. I'll try to explain these two approaches with the help of a simple example. First, let me tell you what is the unification. Unification, I write that here. Unification. Unification is an attempt to explain diverse phenomena with the help of few laws and concepts. I repeat, unification is an attempt to explain a diverse phenomena with the help of few laws and concepts. For example, Newton's universal law of gravitation. Newton's universal law of gravitation. Newton's universal law of gravitation explains the reason for the motion of Earth around the Sun, the motion of any planet around the Sun. It explains the motion of Moon around the Earth, and also it explains the motion of freely falling body towards the Earth. So a single law can able to explain many natural happenings. So it is a perfect example of unification. So what is Newton's universal law of gravitation? Newton's universal law of gravitation says that there is a force of attraction between two objects present in the universe. If you take any object, there is a force of attraction between me and this wall. There is a force of attraction between the table and the chair. So, if you take any two objects in the universe, definitely there will be a force of attraction between them. So that force of attraction is directly proportional to product of their masses and inversely proportional to square of distance between them. This is the Newton's universal law of gravitation. We will discuss about this in detail, maybe in some other video. So this law unifies many concepts of physics. Now we'll move ahead to reductionism. Let me tell you what is reductionism. Reductionism is an attempt to explain macroscopic system with the help of its microscopic constraints. We come across the bursting of tubes, cycle tubes during summer season. It is due to the high temperature in the surrounding. This happens due to expansion of air or gas present inside the tube. We study about the expansion of gas in thermodynamics. If you want to know the reason, then we move to kinetic theory of gas. So this method of explaining a macroscopic system with the help of its microscopic constraints is referred as reductionism. Now we'll move ahead to another topic. Now we'll classify physics. Physics is broadly classified into classical and modern physics. What is the classical physics? Classical physics. Classical physics is nothing but the traditional physics that was present before 20th century. I repeat, the traditional physics that was present before the 20th century is referred as classical physics. And the concepts of physics that was evolved at the beginning of our 20th century is referred as modern physics. Now, I will give some of the branches of classical physics. Like this, classical physics. Classical physics. In classical physics, we have classical mechanics. And then we have thermodynamics. Then optics. Then apart from this, we have electricity, magnetism, acoustics, then astrophysics, and eighth one is relativity. These are some of the branches of classical physics. I'll tell you what these things are one by one. Here, classical mechanics is the branch of physics that deals with the study of forces acting on objects either at rest or in motion. And thermodynamics deals with the study of heat, whereas optics is the branch of physics that deals with the study of light. In optics, we study about light. In electricity, we study about the moving charges. Magnetism is the branch of physics that deals with the study of magnet and their property. Acoustics is the branch of physics that deals with the study of production of sound and it also deals with the propagation of sound. I repeat, acoustics is the branch of physics that deals with the study of production and propagation of sound waves. In astrophysics, we study the physics of astronomical bodies. And last one is the relativity, most interesting branch of physics. It studies the relationship between space, time, and energy of moving bodies. So in relativity, we study about the relationship between space, time, and energy of moving objects, in simple words. So these are some of the branches of classical physics. Now we'll move ahead to modern physics. We'll discuss some of the branches of modern physics. Let me write on the board modern physics. I write some of the branches of modern physics. Only one. The atomic physics, then nuclear physics, we have condensed matter physics, condensed matter physics, then high energy physics, high energy physics. Now let me tell you what these branches of physics deals with. First, atomic physics. Atomic physics is the branch of physics that deals with the study of structure and properties of atom. And the branch of physics that deals with the study of structure and properties of atomic nucleus is referred as nuclear physics. Then it comes to condensed matter physics. In this branch of modern physics, we study about the properties of condensed material, such as a liquid or a solid. And high energy physics. High energy physics deals with the nature of particles. So these are some of the branches of modern physics. Now let's discuss the scope and excitement of physics. Scope and excitement of physics. Here, scope represents the range. Physics has got a huge scope as it deals with a system with a large magnitude, and it also deals with system with a very small magnitude. If we talk about the mass, in physics we study about the mass of the entire universe, and we also use a very tiny mass, that's the mass of electron. So it won't be wrong if we say that physics has got a huge scope. Huge scope. Now let's come to the excitement of physics. We not only learned physics to gain knowledge, but the learning of physics can be an excitement. Now, man can able to send rovers to moon and also to other planets only with the help of the principles of physics. No? We can able to send rovers, and we can also able to control those rovers with the help of remote controls just by sitting on the surface of Earth. Now, next, physics in relation to technology and society. Physics in relation to technology and society. Now, before going ahead, let me tell you what is technology. Technology is the application of principles of physics for the benefit of or for a practical purpose. I repeat, technology refers to the application of principles of physics for practical purpose. So there are many things we come across in physics which is used for the benefit of human beings, which is used for practical purpose. So physics and technology helps the society in many ways in the development to make the work of a human being become easy. Suppose if you take the example of raising property of hot gas, when gas becomes warm, they raises. This property is used in a beneficial way. We keep the ventilators at the top near the roof. Even exhaust fans are mounted near the roof for the reason that when air becomes hot, they raises. In order to remove that warm air, we keep the ventilators and exhaust fans at the top. This is the application of principle of physics to help the society and human being. I hope the video is useful. If you have any kind of doubt related to the topic, kindly put your questions in the comment section. Thanks for watching.